Another cool thing we can do with timers is use them to time code to see actually how long things take to do. And the basic setup would be something like this. Here's open timer 2, and we've set it for a certain amount of time, about 2 seconds, right? Here we clear the flag and we start the timer at 0. If there's any code in here, then that takes time to execute. And when it's finished, we read the timer. And we should also get the flag, because the time that we find will be based on our counter. Okay, actually, so this should be a little typo here. This should be counter. Whenever the counter reads, since it started from 0. If there was no overflow, then times n times the instruction cycle should be perfect. If the flag overflowed once, then we would just add one full cycle. Okay? So let's see an example of how we could do this in code. Okay? So what I have here, let me maximize this, get rid of this over here, is I have used timer 3, and the piece of code that I'm using to time is simply this print statement, timing code execution. We want to see how long that takes. Right, so the timer's open. I clear the flag and rate the timer to 0. Okay, I have whatever lines of code I want. Could be one line, could be many lines. Then I get the flag and read the timer. Then I can use the formula we just talked about figuring out how much time was involved. So here I'm printing out 3 bits of information: the counter, the flag status, and the calculated time in seconds. Here I'm doing the same thing, but I'm doing it for a delay of 300 milliseconds. We'll see how accurate that function is. Okay? And then I'm doing it for 500 milliseconds. So let's look at the output in PuTTY. Here we go. Okay? And the first one is, it gives me the counter was 979, right? And doing all the calculations with my counter being 969, there's no flag to worry about. We find a time of about almost 8 milliseconds. Down later, we've got 2 counts, one for 300 milliseconds, and according to the counter, I'm bang on for the 300. The next one, 500, it says, oops, no, you only asked for 0.1 or 100 milliseconds. But the reason for that is the flag is overflowed. Now, if you're reasonably sure the flag is only overflowed once, all you have to do is add how much timer period you had. So if I go back here, right, and here's this guy, so 49999 plus 1 times 64 times 1 over 8 megahertz, that's 0.4 seconds. And that's consistent with what we're seeing here, right? 0.5 seconds, the amount I asked for, is 0.4 plus 0.1. So if I had included this overflow, I would in fact have had the correct amount of time. But you can never be sure that a flag is overflowed by only one time, right? So if I had put 2 seconds worth of delay, right? So if I put in 2000, right, it could look the same, right? So you had to be very careful about using the counter when the flag is overflowed. That's all for now.